Hello students, welcome back. We're going to continue talking about the costs of production. And so where we left off last time, we had talked about various measures of costs, and specifically we wanted to emphasize that the costs of a firm are related to its production. We talked about the idea of diminishing marginal productivity, and specifically what's going on is there are fixed factors of production, the fixed inputs of the firm, those that lead to their fixed costs. And because the firm has some fixed costs, ultimately that's going to cause the marginal product to diminish, or what we sometimes call diminishing returns to fixed factors of production. And in turn, that's going to cause the cost of producing additional units to go up. So in this table, you can see the last column in particular is the marginal cost column, and the marginal cost column shows that costs are increasing for each additional unit that the firm produces. Now we're going to talk about the other measures of cost that we're interested in, which are the average fixed cost and the average variable cost and the average total cost too. But notice that the definition of the total cost, the fixed cost, and the variable costs are such that you just take the total costs and divide them by the number of units being produced. So in the case of, for example, in this table, look at the quantity 2 has a total cost of 380. And therefore, if we move over to the average total cost column, we see 380 divided by 2 is 190. And so by analogy, you can look at the fixed costs and get the average fixed cost for producing a certain number of units and the average variable cost, and look at the quantity associated with that level of average variable cost and compute the average variable cost. So that's what's captured in this table. So we already mentioned that marginal costs are going to be increasing, but we'll give you a mathematical definition of the marginal costs. If we were to compute them from the table, it would be the change in the total cost divided by the change in quantity. So in the next slide, we're going to go ahead and highlight the two columns, and here's the slide. It's the quantity of output, and then you see the total cost and you see the marginal costs for the firm where we displayed the data before. And so you can see as we move from producing no units, 0 to 1, our total costs increased by 30. So the marginal cost of the first unit is 30 cents. That was the data we displayed on the table before. And as we increase from 1 to 2 units, our total cost increases from $3.30 to $3.80. So our change in our total cost was 50 cents, and that's our marginal cost for producing the second unit, and so on. I'll just do one other example. Moving from producing 9 to 10 units, you can see we moved from a total cost of $12.90 to $15, which is a change in total cost of $2.10. So our marginal cost, our additional cost of producing the 10th unit, is $2.10. So now we'll see, since our costs are increasing, our total costs are going to be increasing. So our costs of production on the margin, our marginal costs are increasing. And so if you look at the slope of this curve, the slope is increasing. The slope gives us the marginal cost. It gives us the change in total cost. So we'll just go back and we'll look at quantities 9 and 10 again. And you can see the total cost curve goes up from what we had before, which was, we'll go back and we'll look just to be sure we got it right, from $12.90 to $15. So here we've got $12.50 to $15 as being our change. Sorry, $12.90. And so that additional segment, that slope is our marginal cost for our total cost curve. Now we can plot the average total costs and the average fixed costs and the marginal costs together. So this slide And I'm also going to plot the average variable cost on there. And there are a couple of things you can't really see here, but I want to make sure I tell them to you because it's important for problems that you'll solve. So the marginal cost curve is going to intersect the average total cost at the minimum of the average total cost. We call that the efficient scale of production, the quantity that's associated with the minimum average total cost. And you can't quite see it here because the graph isn't complete, but the marginal cost also intersects the average variable cost at its minimum point, and that becomes important a little bit later in the course. So marginal cost rises with the amount of output, and that reflects that property of diminishing marginal product, or what we call diminishing returns to fixed factors of production. And so we have this increasing marginal cost curve. The total cost curve is got a U shape to it. At very low levels of output, average total cost is dominated by fixed costs, and the fixed costs are only spread over a few units, so the average total cost is high for low levels of production. And then the average total cost declines as output increases, and then average total cost starts to rise as the variable costs begin to rise. And one of the things I'll tell you in passing is that if we add up the marginal costs, we can get the average variable costs by themselves. So the area underneath the marginal cost curve gives the sum of the marginal costs and gives us variable costs. So that's one of the relationships that's important. And again, I already told you guys about the efficient scale, but here we're going to emphasize it. It's very important that the average total cost curve is intersected by the marginal cost curve at the efficient scale. So in this diagram, we have the average total cost curve by itself, and we can see that its minimum is at about 5 units. That's going to be the efficient scale. So here's the relationship that I've been discussing. Whenever the marginal cost is less than the average total cost, it's going to cause the average total cost to fall. And whenever the marginal cost is greater than the average total cost, it's going to cause the average total cost to rise. And so that means that the marginal cost curve is going to intersect the average total cost curve at the efficient scale, at the quantity that minimizes the average total cost. So here's the depiction of just the marginal cost curve crossing the average total cost curve at its minimum. Okay. So now we're going to talk about the relationship that exists between the different measures of costs. And this is a really good slide because it shows how total cost is the sum of fixed cost and variable cost, and gives you all the formulas in one place and a nice handy example. So without going into too much detail, I think the one of the main takeaways from this table is that you can see if I add the fixed costs and the variable costs for any level of production, I get the total costs. And likewise, if I add average fixed cost and average variable cost, I get average total cost. So that kind of summarizes the relationships and the formulas that we want to be aware of. So here's our total cost curve depicted based on the data that we had and the associated marginal and average cost curves. Now here we can see clearly that it's also the case that the marginal cost curve is going to intersect with the average variable cost curve at the minimum of the average variable cost curve also. And that's going to be important to us a little bit later. So make sure you remember marginal cost is going to intersect both of the average total and average variable cost curves at their respective minimum points. And another important detail is that the average fixed cost is always going to be declining. If you remember the formula, the average fixed cost is the fixed cost divided by the level of output. Since the fixed cost is a fixed number, that ratio is going to fall as quantity goes up because the denominator is increasing while the numerator is staying constant. Three important properties of cost curves. Marginal costs always eventually rise with the quantity of output because of diminishing returns and diminishing marginal productivity. So I'll just click back to the last graph, and you can see here marginal cost declines, but then eventually diminishing marginal productivity or diminishing returns kicks in, and from that point on, marginal costs just increase. And the average total cost curve is U-shaped, and the marginal cost curve crosses the average total cost at the minimum of average total cost, what we call the efficient scale. So those are important points to remember. The last thing that we want to talk about is this difference between costs in the short run and costs in the long run. We haven't really talked about that much, but really the difference is that in the long run, firms can vary all of their inputs, including those inputs that in the short run would be fixed. So for example, if we think of a company that rents a factory or has a factory, usually that's considered a fixed cost. But if you imagine a longer planning horizon where they can expand or they could reduce the factory to a smaller size or get rid of the factory altogether, then that fixed factory cost becomes variable in the long run. So it depends upon the planning horizon whether or not we're in a short run or a long run scenario. So in the short run, some fixed costs exist because we have some fixed inputs, like a factory, for example, that we can't vary in size. But in the long run, those fixed costs become variable costs, and we only have variable costs in the long run. So our total costs and our variable costs are the same in the long run. So because many of these fixed costs in the short run exist, but they're variable in the long run, the firm's long run cost curves are different from the short run cost curves. In particular, because we make no distinction between the average variable costs, for example, and the average total costs in the long run. So here's an example of a U-shaped average total cost curve for a small factory, and this is short run, assuming that the small factory can't be varied. And here's an average total cost curve for the same firm running a medium-sized factory. And here's the same business again using a large factory. And we're talking about large and small factories based on the quantity of production that's possible. You can see we've got quantity on the horizontal axis, and at large levels of output, we have the large factory. And also notice that for this business, a small factory is good in the sense that it has a lower average cost of production for small levels of output. And a medium-sized factory is best for producing in the mid-range of output because the average total costs are lower then. But if you're going to have a really large level of output, you're going to do better with a large factory. That's going to be the way that you achieve the lowest average total costs. So there are reasons based on the quantity that you're planning to produce that you might want to vary your factory size. But again, that's a long run decision. And in the short run, the firm, if they've got a medium-sized factory and they're going to try to ramp up their output and produce more, they'll be stuck producing at an inefficient level with a factory that wasn't designed to produce that many cars, and that's going to force their average total costs to be higher than they otherwise would be. So look at the intersection points of these curves, and you can see that around 1200, a little bit higher than 1200, if you have the medium-sized factory, you'd rather switch to the big factory. So the red line that you see here is the long run average total cost curve. And notice if we varied the factory size even more, we can imagine that the long-run average total cost curve captures what we call the lower envelope of all of the possible short-run average total cost curves. So it's lower than all of them because you're varying the factory size in order to get the lowest average total cost, regardless of what size of factory you need. And you can only do that in a long-run planning environment. So one of the takeaways is that your long-run average total cost will always be lower than any short-run average total costs, except for maybe one point that they share in common. But in general, long-run costs are always lower because the firm has more flexibility than their short-run costs. And we have these concepts of economies and diseconomies of scale. So economies of scale refer to the property where long-run average total cost curves fall as you increase output. Diseconomies refer to the property of long-run average total costs increasing or rising as output increases. And constant returns to scale is a property where long-run average total cost curves stay the same as you're increasing output. So if we look at our graph again, we can see that there's this region of economies of scale where long-run average total costs are falling as output's increasing. And then there's this broad region of constant returns to scale, where as you increase output, long-run average total costs are constant. And then there's this increasing region of diseconomies of scale, where as we increase the quantity of output, we're actually increasing the cost, the average total cost in the long run. Okay, so in summary, the goal of the firm is to maximize their profits, and that's where their total revenue, or the profits of the total revenue minus their total costs. And when analyzing the firm's behavior, we're going to focus in on this cost question. First, we want to know how are they going to minimize their costs. Costs include all of those opportunity costs of production, both the implicit and the explicit costs, as we mentioned before. And some opportunity costs are explicit while others are implicit. The implicit ones are the ones that we don't have a receipt for, like the cost of the owner's time, the person that owns the company, or the cost of idle equipment. And a firm's costs are reflected by its production process, and typically the firm's production function gets flatter because you have diminishing marginal product, and that causes all of the phenomena that we've discussed about costs, in particular that marginal costs are increasing, and that fixed costs don't change, and so forth. And on the next slide, there's a good summary of this. Average total cost is going to be this total cost divided by the quantity of output. Marginal costs is simply the increase in total costs if we increase output by 1 unit. Marginal costs are going to rise with the quantity of output as soon as diminishing returns kicks in. And average cost falls at first and hits the efficient scale and then rises, and that's where the marginal cost intersects with the average total cost. Thanks very much, and I'll be talking to you soon.